All right, so 3.5 here, we're going to use our data from shoe size and height. So continuing that discussion here, and we're going to do a little more with that, and particularly looking at how we predict things using what we call regression lines, that least squares regression line that we were talking about, and kind of guessing what that line of best fit would be. Now we're going to figure out what that is and use that specifically to predict. Now, so our context is say, suppose someone drops AP Stats to join our class, and we only know their height, not even gender. And their height converted here to 168.91 centimeters. How could we use our data to predict the size of their foot? So what we're going to do is we're going to go to our Statlet and make our scatter plot. So we'll jump over there. And so I've already entered in the data. You have this data as a data tab in Canvas, and you can enter this as well to get some practice with this. So I've entered the height and foot size for all students in our periods 1 and 2. And there's our scatter plot. And then what I want to do is I'm going to come down. We can do correlation, right? But then what I really want is I want to calculate this least squares regression line. Okay, and so as you can see, this gives us that line that's kind of balance all of those points. It gives us a couple other things. We'll talk about those here in a little bit. But what I am interested in initially is our equation right there. So I'm going to write that down. All right, so we've written that down there. So we have y, that little caret. So that's y hat, all right? So that's called y hat, which is our predicted value, equals negative 3.83604 plus 0.1617x. All right, and so remember x is our height, and then y hat is our predicted foot size. Right. And another way you might see these written out is one you're maybe more familiar with, as y hat equals 0.1617x minus 3.83604. And that is similar to your y equals mx plus b formula, right? So our slope-intercept formula, which those are the same thing. We'll talk about those here in a little bit as well. Another way you may see this get written out is contextually. And so we may see it written as foot size with the hat equals negative 3.83604 plus the 0.1617 times height. So a reminder contextually what those mean. Again, it's predicted foot size. That's that foot size hat in a sense there. All right. Statistically, for whatever reason, they do the y-intercept first and then your slope and your x value. But all three of those are acceptable variations of that equation. All right, now what can we do with this? Well, that takes us to 2. We can use that equation now to predict the foot size for anyone. And so we have their height of 168.91. So we can substitute that in for x for the height. And so I get our equation y hat equals negative 3.83604 plus 0.1617 times our 168.91. Okay, so then after working that out, we get y hat equals 23.476. So we'll go for 8. And remember, that is our predicted foot size. All right, so then 3, after the student joined, their foot size was measured to be 22.23 centimeters. Was the prediction from number 2 too high or too low? And then how far off were we from that? And so with this, to figure that out, is we go actual minus predicted. And so our actual was 22.23 minus our predicted, which was 23.48. Okay, and so that gives us a negative 1.25. So a couple things to answer. So first, all right, 23.48 is greater than 22.23. So we were too high. And then how far off? We were negative 1.25 centimeters off. And so what that then brings us to is this idea of a residual. All right, remember that graph I kind of pointed to? And that's where this is. The residual is the difference in those. Our actual minus predicted. Or the more specific is y minus y hat, right? The y is our actual, y hat, again, is our predicted. And so then our statement based off of this would be the actual foot size is 1.25 centimeters below the predicted value. And so graphically, what this looks like, all right, if we have a grid like this, we have some line. So there's our regression line there, and we have our point, which was 23.48. And then our actual, which was 22.23. And so that gap there is the residual. All right, so now we want to predict the foot size for a young child that is only 3 feet 8 inches. Okay, convert that to 111.76 centimeters. And so substituting that value in, all right, so we get y hat equals once we work that out, we get 14.24. Now, the question is, would you trust this prediction more or less than the prediction you made in number 2? And I would say less, and our reason is what we call extrapolation. And what this means is when we are predicting a value that is far away from the data. So in this case, give you a visual. All right, we have a bunch of our data up here of us high school kids. And then we have this data point down here of this younger kid that's far away. And so we're extrapolation and we're predicting a value based on data that's further away of something here. And so we know certain things about a young child, and then eventually we get into puberty, and then we explode in our growth. So it's not all linear, and we're trying to predict with a linear model, and so not as trustworthy of a prediction. All right, let's wrap these up. Like I said, coming back, what is the y-intercept of the regression? So remember that y equals mx plus b. So then that y-intercept is that b value. So that's that right there. So negative 3.83604 is the y-intercept. And our x value during this is always 0 when we have a y-intercept. This is where, if we draw a line all the way out, where it crossed the y-axis. And so then the question is, what does this mean? So in context, that would mean, remember, 0 is our height. So theoretically, we can have 0, and theoretically, we can have negative. But what this means, as this individual, this person, has no height and a negative foot length. All right, so as we think about this, is that possible? No, and that's what we would call nonsense. So in prediction models, right, this is a line that will go on forever. We can get to points that don't make sense contextually. We can't have someone with no height, and we can't have a negative distance, a negative measurement, so that it doesn't make sense for us. We will still talk about it, and it's helpful to maybe graph at times, but in the context, this actually does not make sense. All right, and then last one is our slope. All right, so again, going back up to our y equals m. M is our slope, so that is our slope there. So 0.1617 is our slope. Another way to talk about slope is this idea of rise over run. And so our rise over run here, so our rise is that 0.167, and our run is just 1. It's easy to make it over that, right? And so visually, all right, we have some line that has a slope, and so we're going to have this here. So we run 1 centimeter, and then we rise 0.1617. And so what does this mean? It means that for every 1 centimeter of height, the predicted, which is important, foot size increases, right? Because it's positive, we're going up. You can have negative slopes. Foot size increases by 0.1617 centimeters. So that's what it means. It's also our interpretation of that. And that's kind of your sentence frame there. And the important things are this idea of 1 centimeter predicted, and then your distance there. And then don't forget about our context of what your X and Y are in that case. All right, so let's formalize that for you. So give you a chance here to copy all of this down. Okay, let's talk through some of this. So regression, hey, is we're going to fit a line. As we already talked about, the y hat equals mx plus b. It's our predicted y value, our slope, and then our y-intercept. Often in stats, though, they write it in terms of y hat a plus bx. So be careful when you see the generic term, right? That's our m, and then our a, b, they kind of flip those things. Once it's all written out, It doesn't matter the a, b, mx. Just remember your slope is always next to your x. All right. Big thing is beware of extrapolation. Okay, so looking at data that is really far away and trying to predict data, we want to avoid extrapolation. Okay, and then our residuals, we talked about those. The residual is actual y minus predicted y. There's your sentence frame for that. We want to talk about above or below, if it's positive or negative. And then our sentence frame for y-intercepts. So when x equals 0, the predicted y is, and then whatever that is. And then we can state whether that makes sense or is nonsense in that terms. Okay, and then we have our slope there as well. And you've seen that as we did that problem. All right, get those copied down and then work on those problems down below. And I will have those written up for you so you can check your work there as well. All right, so there's our key things that we need. All right, so there's your slope and y-intercept with the sentence frames there, matching what you have up in the notes. All right, and then looking at 10 tablespoons in our graph, right? So we're at 3, so 10 would be 3 times that amount. And so the answer would be no, due to extrapolation.